Okay, then also tomorrow you're going to be taking your first assessment, the first one over exponents, and you'll get a sheet of scratch paper for another part, this part right here. This is going to be the... Okay, these first ones are easy. 3 to the 4th. 3 times 3 times 3 times 3 is 81. Negative 3 times negative 3 times negative 3 times negative 3 times negative 3. And I want it written out like that. $729. It is positive because I had an even number of negative factors. Negative 2 to the 3rd. Negative 2 times negative 2 times negative 2. Negative 8. The reason it's negative because you had an odd number of negative factors. Fractions are not hard. You just go 1/7 times 1/7 times 1/7 times 1/7. And then 1 times 1 times 1 times 1 is just 1. 7 times 7 times 7 times 7 is 2,401. Easy enough. Now this part. When I have to simplify exponent expressions, I'm going to want 3 boxes on each one. Set that up. It's going to help you, but you have to have the gumption to do it. Okay, so the first thing I do is underline the whole expression if I don't already have it underlined. And then, so my bases in the problem are 2. And then another number base I have is 7. And then that's it. The rest of the numbers are exponents. And then for letter bases, I just have X. It's the only letter I have, so put that there. Okay, so 2 to the 1st, but it's in parentheses, so 1 times 3 is 3, so it's to the 3rd. 7 to the 1st, 1 times 2 is 2. And then X's, well, how many X's do you got? You got 2, so you need to write 2 numbers here with a comma. 5 times 3 is 15. And 7 times 2 is 14. So now I got to decide what I'm going to do with 15 and 14. Well, that X is on top of the line that I drew, and that X is on top, so I just add, and that's 29. So that X is to the 29th power. Now look at your little powers, 3, 2, and 29. Are any of them negative? Nope, that's positive, so that stays where it's at. That's positive, that stays where it's at, and the X to the 29th stays where it's at. Okay, now you figure out the ones you can. You can figure out 2 to the 3rd. 2 times 2 times 2 is 8. And 7 to the 2nd is 49. Times X to the 29th. Now you have these 2 big numbers here on top together, so you need to actually multiply them. So 8 times 49 is 392. 392 times X to the 29th is simplified. Okay, my next one. Base number's 4. That's the only base you really have for numbers. You got more 4s here, but you should only write a base down once. There's no letters at all. So I have a 3, a 2, and a 5. So what am I going to do with 3, 2, and 5? Well, the 4 to the 3rd comes from the top, then we go to the bottom. When you go top to bottom, you got a minus, and don't stop minusing. So 3 minus 2 is 1. 1 minus 5 is negative 4. So that 4 is going to be to the negative 4th power. Now the little power is negative, so you got to move your 4, the big 4, to the bottom so that the little 4 becomes positive. And then we can't have the top empty. You need to put a 1 there. So I got 1, and I can figure out 4 to the 4th. Is 256. Okay, my next one, extend your line so it goes across. And then on top, I've got a base 3. On bottom, I have a base of 4. And then for letters, I have a base of X on top. I have a base of X on bottom. Don't write X again. Okay, once is good enough. And then I have a base of B on bottom. So 3 is to the first, no parentheses, so it's just to the first. X is to the third, but it's in parentheses, so 3 times 7 is 21. That's the only X you have. And then no, it's not the only X. I'm an idiot. There's another X here, okay, with a 10, so comma 10. So I got to figure out what I'm going to do with 21 and 10. Top, bottom. Minus, so that's 11. So that X is to the 11th power. Okay, now the 4 is to the first, so it's just no parentheses, so we're putting a 1 there. And then B is to the first, but there's a parenthesis surrounding it, so 1 times 7 is 7. Okay, none of these powers are negative, so we don't move anything. 3 to the first stays where it's at. X to the 11th stays where it's at. 4 to the first stays where it's at. And B to the 7th stays where it's at. So 3 to the first I know is 3. I can't figure out X to the 11th, so I just leave it like it is. 4 to the first is 4. B to the 7th is going to stay. Now the big numbers here are on different sides of the line. They're not on the same side like they were up here, so I just leave them. Don't do anything with them. Okay, next one. Underline. Remember, put your own line there. What number bases? You got 3. What letter bases? You got X and Y. So 3. 1 times 3 is 3. How many X's? There's 2 of them in the problem. So negative 2 times 3 is negative 6. Comma, and then there's a 5. So I got to figure out what I'm going to do with negative 6 and 5. So that comes from, both of them are on top, so that means we plus them together, and that's negative 1. Okay, and then the Y, there's only one of them, and 2 times 3 is 6, so to the 6th. Now 3 to the third, the exponent's positive, so leave it where it's at. The X needs to move to the bottom so that its little negative 1 can become positive 1. And then the Y stays where it's at, so its little 6 can become 6. 3 to the third means 3 times 3 times 3, and that's 27. Times Y to the 6, I can't figure out Y to the 6th. And then X to the first. Okay, scientific notation. Write 0.0000273 in scientific notation. Okay, so here's what we do. It's smaller than 1 whole, so the exponent's going to be negative. So remember, scientific is something times 10 to the power of something. Okay, here's the first decimal. Now from going this way, I have 0, 0, 0, 0, 0, 0, non-zero, so 2. Okay, first digit that you go this way, that's not a 0. That's where you're going to put your new decimal. So I have 2.73 times 10. Now count the digits between your decimals. So 1, 2, 3, 4, 5, 6. 6. But since it's less than 1 whole, it needs to be negative. Okay, 2.83 times 10 to the 8th in standard form. I just need to find out what actual number that is. So 2.83, and then we have a positive exponent, so the number's going to grow. It's going to go this way. So 1, 2, 3, 4, 5, 6, 7, 8, and the decimal's at the end of the number, so I don't need to put it in my answers. So 283, by the way, you don't put that one in. The old decimal you leave out. 283, 0, 0, 0, 0, 0, 0, So 283 million. Okay, now story problems with this. There's 2 units in each one, underlined years and money. So we're going to need to go with our variables, our path, and then our equation. Now this problem, it would more be like cross out 30,000, put 300,000, because that's more realistic for a tractor. Farmer bought a tractor in 1999 for $300,000. The value of the tractor has been decreasing at a rate of 18% per year. How much is the tractor worth in the year 2015? So I've got years and money. X is years, Y is money. So dollars per year. Well, I don't have a dollars per year, but I have a percent per year. So it's percent per year. And it's 18%. Now it's decreasing because it gets older. And with percents, we don't make a line because the rate of the change isn't constant. Instead, we make a curve, and it's X comma Y. G, put that upside down V so you know it's G to the X power, and then a Y. So we got to have a number here, which we have. We have 300,000. And then my growth factor, and by the way, times, always put times there and circle it. So the growth factor, I always take 100%, I minus 18%, so 82%, and that's going to be 0.82. Anything less than 100 is 0 point. So I've got 300,000 times 0.82 to the X power equals Y. Okay, now the X is years. This is what I'm going to replace, but I'm given 2 years, so I need to find out how many years were in this span. So I take 2015 minus 1999, and that's 16. So to the 16th power, and then I just plug that into my calculator to get my answer. So 300,000 times 0.82 to the power of 16, 12,536. Okay. Highly unlikely a tractor ever gets that cheap, but whatever. Okay, a family buys a house for $150,000 in the year 2000. The value of the house increases at an annual rate of 8%. Find the house's value after 5 years. Houses get higher in value because you own property, and property is always getting higher. So again, 2 units, and then my equation. So I've got money in years. X needs to be the years, Y needs to be the money. So dollars per year. I don't have a dollars per year, but I have a percent per year. Annual means it's per year, so that's a percent. It's 8%, but this is going up, okay? So again, X comma, put a times there, X comma Y, G to the power of X, and then Y. So we have 150,000, that's what your money starts with. To find your growth factor, you start with 100%, and we're going to add 8% because it's going up. So that's 108%, which is 1.08. So my growth factor is 1.08. So I have 150,000 times 1.08 means 108%. To the X power equals Y. Okay, so get your X out. X is years, and we know there's 5 years. So 5. And then I can calculate that. So 150,000 times 1.08 power of 5. So that's $220,399. Okay, we'll continue to review in the next coming days.